Hello guys, this is your teacher Renada Saab. I have now a new chapter that's called ions and I'm gonna go over some important information in here. As usual, I expect that you read everything and understand them perfectly, and I do believe in you. Um, I spend time writing these notes and making sure that the sample is easy to understand and follow. So please spend some time to read these, and I believe that you will. Um, I'm gonna try to make those videos around 10 minutes, and I would appreciate if you give me your undivided attention for 10 minutes. Again, as usual, you will find these notes in my website under nhsab.weebly.com and under chemistry notes. So please go to this site and then download the PDF file. Page 1 here. In page 1, just the two simple things. Electrons and protons have the same charge, opposite signs, so one proton and one electron, they add up to 0. Okay, this is the atom here. We've seen that before. Energy levels and then maximum number of electrons on each energy level. What are ions? Ions are atoms with a charge. Cations are usually positively charged, anions are negatively charged. You see them here. Why do atoms form ions? Atoms form ions to be stable. How to be stable? They can be stable by looking like one of the noble gases in group 8. Noble gases are stable somewhat because they have 8 electrons on the outer shell, or 8 valence electrons. So atoms lose or gain electrons to look like one of the noble gases, and the other name for 8 is octa. So that's why you call this also octet rule. So tendency to have 8 electrons on the outer shell and be more stable. And here I put the noble gases for you, the first 4 noble gases. Please note that they have 8 electrons on the outer shell, except for helium has 2, and that gives them somehow stability, so that every atom to be stable has to look like one of them, one of the noble gases. Okay, and this page here, I wanted to read exactly what I put on in this table. So when an atom loses electron, it will have positive charge or cation, and the size of the cation is smaller than the size of the atom. The name of the cation is the same as the name of the atom. So I put equation, size, name. The same thing here for the anion. When an atom gains electrons, it becomes a negatively charged anion, and the anion size is bigger than that of the atom. And I want you to pay attention that the name of the anion has to end with IDE. So we take the name of the atom and then we add to it IDE, like a chloride, sulfide, bromide, etc. Okay, now let's see what happened with element of a group 1. The element of a group 1 will gain 1 electron and become positive charge, 1 positive charge. I put for you here the potassium as an example, and I wanted to read this example because I have more explanation about it in the next page. Okay, this is can be a lot clearer. So okay, let's see. This is a potassium here. It has 19 protons in the nucleus, 19 electrons. The last energy level has 1 electron. So if you notice here, if potassium loses this 1 electron and will be left with 8 electrons on the outer shell, so it will look like the noble gas argon with 18 electrons. So potassium will lose this 1 electron and then it will have 1 positive charge. Why? Because it will still have 19 protons in the nucleus, but now the electrons are 18, so the total is +1. For this size, please notice that when losing the electron on the outer shell, we're going from 4 energy levels, 1, 2, 3, 4, to only 3, 1, 2, 3, so the size gets smaller. That's why we say that the potassium cation is smaller than the potassium atom. Okay, and here I discussed it that group 2 loses 2 electrons and become 2 positive charge, again 2 positive charge. This is also an example. I gave you magnesium as an example, so please read it. Group 3 lose 3 electrons, 3 plus, and this is aluminum as an example. Now we get to group 5. It's a little bit different because the element of a group 5, they have 5 electrons on the outer shell. They need to have 8 electrons, so an easy way to do this is to gain 3. Instead of losing all 5, they can gain 3 and have 8 electrons on the outer shell or octet. Okay, when an atom gains 3 electrons, it will have 3 extra negative charges, and now it's an anion. So all elements of a group 5 form anions. Okay, now this is what I just explained. I have here nitrogen as an example. Nitrogen has 7 protons, 7 electrons, 5 on the outer shell. So it can easily gain 3 electrons. When it does this, it will have 8 electrons on the outer shell. Okay, so it is here now. It will have 3 negative charges and it will look like neon. So we'll have 10 electrons that looks like neon. So notice here, have 7 proton and 10 electron, total charges is 3 minus. Now for the size of the atom and comparing it to the size of the anion, please notice that they both have 2 energy levels. So what to do? Here you have 7 proton pulling 7 electron, but here you have 7 protons pulling 10 electrons. So I would say that this will pull the electron closer. The nucleus will pull the electrons closer. So this size of nitrogen is bigger than that of the anion. I'm sorry, it's smaller. So the anion is bigger than that of the parent atom. Okay. So again, element of a group 6, they have 6 electrons on the outer shell. They gain 2 electrons to have 8, and they have the charge will be 2 minus. I give you as an example here oxygen. Please read that. Element of a group 7 have 7 electrons on the outer shell. They need only to gain 1 to have 8. So when they gain this 1 electron, they will have 1 negative charge. And then in all of them also, please notice that the size of the anion is usually bigger than the size of the atom. Okay, this is a kind of summary. Please notice that all elements of a group 1, they have 1 plus, 2 plus, 3 plus. When it comes to 5, so it'll be 3 minus, 2 minus, 1 minus. So those are the anion, and the cation they tend to form. Okay. Alright, and this is the periodic also table somehow. Please notice that the size of the cation is always smaller than the size of the atom, because there is a loss of 1 energy level. But the size of the anion is bigger than the size of the atom, because you add in more electrons, and the nucleus now has to pull more electrons, so it doesn't pull them as strong. And at the end, I have a summary for you here. So like element of a group 1 has to lose 1 electron, group 2 lose 2, group 3 lose 3, group 5 gain 3, group 2 gain 2, group 6 gain 2, group 7 gain 1. And the idea is to have 8 valence electrons, and those are the names. The name of the cation is the same as the name of the element. The name of the anion, you have to add the IDE at the end. So again, please, the idea is to make you think, read through this. I spend the time right